Welcome to the video on compound interest and annual depreciation. So here we have the formula for compound interest. Your final amount equals your principal or your initial amount times 1 plus your rate. So for example, if your rate was 12%, you'd put it as a decimal, 0.12, and then divided by the number of times applied per time period. So this could be calculated yearly, where n would be 1, half yearly, where n would be 2, quarterly, where n equals 4, or monthly, where n equals 12. And then t is the number of time periods. So for example, if it was 5 years, then t would be 5. So here we have a problem that says Weston invested $38,000 in a savings account that pays an annual interest rate of 2.3%. The savings account compounds quarterly. How much money does Weston have in his account after 4 years? So let's start by figuring out what our variables are. So our principal amount, or our initial amount, is $38,000, because that's how much Weston is investing. We need R, so our rate, it says the account pays an annual interest rate of 2.3%. So our rate is going to be 2.3% written as a decimal. So to write a percent as a decimal, you'll divide it by 100. So we get 0.023 for our rate. Then for n, we need to figure out the number of times that it compounds. So here it says it compounds quarterly. So quarterly means 4 times per year. So we'll say n equals 4. And then our t, it says we need to know how much he has in an account after 4 years. So our time is going to be 4 years. So we get A equals P, 38,000, times 1 plus our rate, 0.023, divided by n, which is 4, to our n times t. Then we can enter all of that in the calculator, and we'll find that our amount in our account after 4 years is going to be $41,650.89. So if you just want a generic equation where you could figure out the amount for different lengths of time, you would just have 38,000 times 1 plus 0.023 over 4 to the 4t. And that would give you the amount as a function of time. Next, we'll talk about the real rate of return. So the real rate of return is how much money you're actually making when you take out how much you're losing because of the inflation rate. So your real rate of return equals 1 plus your interest rate divided by 1 plus your inflation rate minus 1. So for this problem, it says Thomas makes an investment where the interest rate is 4%. The current inflation rate is 7%. What is Thomas's real rate of return on his investment? So our real rate of return equals 1 plus our interest rate. So it's 4%. When we turn that into a decimal, we get 0.04. So we'll add 0.04 over 1 plus our inflation rate, which is 7%, divided by 100 is 0.07, minus 1. So when we enter all of that into the calculator, we get that the real rate of return is negative 0.028. So if we change that to percent, we'll multiply it by 100, and we'll get a negative 2.8% is the real rate of return on the investment. So Thomas's money is actually losing value. Next, we have depreciation. So depreciation is basically the same as our compound interest, except that the rate is negative. And the rate is negative because the amount is decreasing. So here it says Ethan buys a car for $12,000 in 2010. Each year, the car's value decreases by 7%. How much will the car be worth in 2017? So we don't know our amount. Our principal or initial amount is $12,000. Our rate is 7% divided by 100 is going to be 0.07. And it says the value decreases. So our rate is a negative 0.07. N is going to be 1 because the car's value decreases each year by 7%. So it's only happening once every year. And then T is going to be 7 because 2017 minus 2010 is 7. So 7 years have passed. So we have A equals our principal, 12,000, times 1 plus our rate, which is negative 0.07, over the number of times, 1, times the number of times, 1, times T, which is 7. And when we enter that into the calculator, we see that the final amount that his car is worth in 2017 is $7,220.41. So that's what the car is worth. So in summary, these are the important equations that you need to know for compound interest and depreciation, as well as rate of return. And here are all the variables that go with that. Thanks for watching.